Good morning, students. This lesson is of class 8th for the subject of physics. Topic: examples of first law, which is covered in chapter 3, laws of motion, and is given on page number 61 of your textbook titled Concise Physics by Selena Publications. This lesson is submitted to you on 19th July 2021. Now, students, let us study certain examples of inertia of rest. First of all, we have already discussed in our last week class that what is inertia of rest? If a body is at rest, it will remain at rest unless and until an external force is applied to change its state of rest. This property of body is called inertia of rest. So what is inertia of rest? If a body is at rest, it will continue to remain at rest. It will not move. It will continue to remain in rest only unless we apply a force to change its state of rest. That is, to bring it in motion, we need to apply certain force. Now, children, we are having some interesting illustrations regarding this concept. First example which we'll study today is when a train suddenly starts moving forward, or even you can say the bus. When a bus or a train suddenly starts moving forward, the passenger standing in the compartment tends to fall backwards. The passenger will experience a jerk. Now it happens because the lower part of the passenger's body is in contact with the train. So as the train starts moving, his lower part shares the motion at once. Its lower part comes in motion immediately. But the upper part of the body, due to inertia of rest, cannot share the motion simultaneously, and thus it remains at same place, due to which the lower part of the body moves ahead and the upper part of the body remains behind. Thus, the person experiences a jerk. Now, children, I want you all to see this specific video. Here also, the same concept has been shown to you. See, students, in this bus, this person is standing. Now, when the bus will start, the person will experience a jerk. See the man standing here. Look, can you see this thing? Even the woman sitting behind on the seat is also experiencing the jerk. See, students, the jerk was backward. Again, have a look. See, isn't it? So, even if you see the lady, the female sitting behind, she will also experience a jerk backward. So now why this is happening, children? There must be certain reason. This is inertia of rest. Now what happens here? Look, children, the man was standing, his foot was in contact with the base of the vehicle. When the vehicle comes in motion, the feet of the man immediately comes in motion, while the upper part of the body remains at rest. It doesn't come in motion simultaneously at the same time. So, see students, what is the situation here? A situation occurs that is shown right now to you. So what is occurring here? See, originally the man was standing at this place. When the bus starts moving, now the bus is going in a forward direction. So if the bus is going in forward direction, the foot also moved in a forward direction because it was in contact with the base of the vehicle. It comes in the motion instantly. But children, the upper part, the head, see, the upper part of the body is not able to share motion at once, and it is at the same position which was earlier. So that's why this upper body is actually, it is behind your foot. Therefore, you experience a jerk. The foot also go backward. You experience a jerk in a backward direction, students. So see, these are the positions early of the person and he will experience a jerk. Now, similarly, we are having one more example discussed in your PDF. You can do this activity at your home. Take a glass speaker, put an even card on it, and instead of ball, you can keep a coin also. And if you flick this card or you remove this cardboard sheet, then what happens? The ball will not come at once. Children, if you take out this cardboard sheet, the cardboard will come in motion, but the ball, it was at rest. It will not come in motion at once, and you know what will happen? The ball will fall down in the beaker. And why it will fall down? Because it remains at rest, and it falls down because of acceleration, because of gravitational pull of earth. See children, I'll just take out that cardboard sheet and the ball fell down. Isn't it interesting? Very good, children. Similarly, today we will learn one more example which you might have seen in your homes also. When a hanging carpet is beaten with a stick, the dust particles start falling out of it. Now, children, the part of the carpet where the stick strikes comes in motion at once, while the dust particles settled on its fur remain in motion. Suppose you are having a carpet. If you beat this whole carpet, then what happens? The carpet will come in motion. It will move backward or forward depending on from which side you are beating the carpet. But the dust particle in it, we are having particles, dust particle inside the carpet. When the carpet moves forward, then the dust particle, they were not able to share the motion at once. So the carpet came forward, this whole carpet came in a forward direction, in this direction. This carpet is moved in a forward direction now. But children, see, the dust particles are not able to move in forward direction. Rather, they are stuck there only and they all fall down because of gravity of earth, gravitational pull of earth. It is necessary to write down pull of earth. We have to write down whose gravity is pulling the dust particles. Now, children, you can pause this session, and in the meantime, see the picture given in page number 2 of the PDF, and I'm asking you a question. You can write down the answer. So the question is, why does fruit fall down on shaking the branches of a tree? If you shake the branches of the tree, what happens? The leaves and the fruit fall down, isn't it? So your question is, why does it occur? Children, take a 5-minute break and you can resume further to check your answer. Students, I hope you have written the answer. Now see what can be its answer. Let's have a look. Children, initially the fruits and the dry leaves are in state of rest, and they all possess inertia of rest, since whole of the tree was at rest. But when we shake a branch of a tree, the tree possesses a state of motion. That branch comes in motion. It starts vibrating. But the fruits and leaves tends to remain at rest. And therefore, the fruits or the leaves gets detached from the tree. And if they have got detached, they will fall down because of Earth's gravity. Children, similarly, you can try one activity at home. On striking the coin at the bottom of pile of Carom coins with a striker, lowest coin only moves away while the rest of the piles remain intact. Now let us see how. Students, see, this is a carom, and in this carom, I am having a pile of coins. You can do this activity at home. Keep all of the pile, make a pile of coins, and then take a striker. Now, when you flick the striker coin towards the base of the first coin, only the first coin will come in motion. First of all, I want you all to see the activity, and then I'll give you the explanation. So children, see, if you flick the coin, what happens? Only one, the coin at the base, comes in motion. Have a look again. This. Now, why so? Because all the other coins were initially all the coins were in state of rest. As soon as you bring the striker, the motion of the striker is shared with only the coin on which the striker hit. But the rest of the coins are still in state of rest. So they will remain in the same state of rest and thus will not go in motion. Is it fine? So the reason is given in the PDF also, children. See, the reason is that as the striker hits the lowest coin, the lowest coin will share the motion of the striker and will move forward, while the remaining pile will remain intact due to inertia of rest. It will not move ahead. I hope it is clear, children. Now again, kindly pause this session and observe the figure shown below. You can try this activity at your home and see what happens when a smooth card, you have to place a smooth card placed over a mouth of a tumbler, is flicked in a horizontal direction. You are giving a force in a horizontal direction. Children, you will observe that the card will fly and the coin will fall down. It is the same thing which I have shown you with the ball. Kindly try this and then return back for the session forward. Parents, this is the way you can do this question. You kindly, what you can do, take a card and a coin and a glass tumbler. This is a glass tumbler, this is a cardboard, and this is a coin. So what you'll do, you place the thing and flick the cardboard sheet. See, the coin fell down. This activity you can try. Flick the cardboard sheet and coin will fall down. Because the coin has not shared the motion instantly and it falls down due to gravity of Earth. I hope you will enjoy these activities. Now children, let us study the next inertia, type of inertia, and then we'll discuss its examples also. So first thing is, what is inertia of motion? Now, a body in a state of motion, the body is already in a state of motion, it will continue to be in the state of motion with same speed and in same direction in a straight line unless an external force is applied on it to change its state. So if the body is in motion, it will continue to remain in same state of motion with the same speed and with same direction in a straight line unless you apply a force to change its state. Now this property is known as inertia of motion. So children, let's do these examples also. Example 1 is a cyclist while riding a bicycle along a level road does not come to rest immediately after he stops pedaling. Why so? Because the bicycle continues to move due to inertia of motion even after the cyclist stops applying the force on the pedal. So the bicycle comes to rest after some time because of the frictional force between the tires of the bicycle and the road. If there was no friction, students, then the cyclist would not be able to stop himself unless and until he applies force by applying brakes. Second application is when a passenger jumps out of a moving train, he falls down. It is very dangerous to jump out of any moving vehicle, whether it is a train or a bus, because the person will fall down. Why he fell down? Because when the person was inside the train and the train was moving, then the whole body of the person was in a state of motion. Whole of the body was in motion with the train. But when that person jumps out of the train, then what happens? His feet will touch the ground. That means his lower body will touch the ground. And children, if that person touches the ground was at rest while his body is in motion. Then what happens? As soon as you touch the ground, the feet comes at rest immediately. The lower part will come at rest immediately, while the upper part still is in motion. Of course, it happens due to inertia of motion. That's why the person tends to fall in the direction of motion. So, to avoid falling, the passenger's feet should touch the ground. He should start running in the ground in the direction of motion of the train or a bus for some time. Students, now let us have a look for the case of inertia of motion. See, suppose the bus is already moving on a leveled road, and as soon as a brake is applied, since the person is moving, the bus is moving, all the persons in the bus are also moving with same speed in a forward direction. All the persons are also moving in same direction as the direction of bus and with same speed as the speed of the bus. But as soon as the brakes are applied, the lower part of the body is in contact with the base of the vehicle. So what will happen? The lower part of the body will come at rest. The lower part will come at rest while the upper part of the body continues to remain in motion. Isn't it? So the lower part will come at rest, but upper part continues to stay in motion. Thus, when a brake is applied, the body lean forward. So children, see this? See, what happened here? The upper part of the body leaned forward because we were not able to stop the upper body simultaneously. Look here, the bus is moving, all people are moving, brakes are applied, body leaned forward. This is also due to inertia of motion, students. The body came in state of, the lower part of the body came at rest at once, but the upper part was not able to come at rest instantly. So students, the last example which we'll do today is when a ball is thrown vertically upwards by a person in a moving train, the ball comes back to his hand. So students, this happens because when the ball was thrown, it was in motion. The ball was in motion along with the person and the train. It remains in the same state of forward direction even during the time the ball remains in air. The person, the inside air, and the ball, they all moved with same distance due to inertia of motion, and the ball thus falls back into his palms. Now children, I'll show this activity. Instead of a train, we are having a car. Now see what happens. Children, what happened here? Look here. So in this case, if a car is coming, the person threw a ball in an upward direction, and then the ball has also came in with same speed it moved with the boy, and it came back to its hand. How so? Just see, we are slowing down the things so that the things are easily cleared. Now see, a person has thrown a ball. The person is in a car. He throws a ball in an upward direction. The person, the ball, and the air surrounding it are it moving with same speed as that of car. See, the person has moved ahead. I want you all to have a look here. Originally, the position of the person. See, what is the position of the person here? If I talk in case 1, the position of the person is this. And if he starts moving, now where has he moved? He has reached this point, isn't it? Then see, where is the person now gone? Third point. Similarly, the ball was also, first point it was here, secondly it was here, and thirdly the ball is here. Even the air surrounding the whole surrounding of the person is also moving with same speed, children. So look here, even if the person is moving ahead, the ball is also moving along with him and he'll catch the ball finally. So what you can think? Whole of the system was moving with same speed in the same direction as that of the car. Similar happens in a train. If you throw a ball upward in a train, after a while, it will not fall backward. It is not so that the ball, see students, what happened here? We have thrown the ball at its first place, isn't it? So we have thrown the ball in an upward direction at this place, here. Okay, the ball was thrown at this place. Again, see, where is the ball thrown? From here, from this place, the ball is thrown. But the person is catching the ball at this point, C. So the ball has been caught at this point. So children, the car, the person, and the ball has traveled the same distance in this much time. That's why he is able to catch the ball at same point. The ball was thrown, I am showing it with a red arrow here, but it is not falling back at this point because the whole system is continuing to move forward with the speed of car. Okay, students, I think now it is clear to all of you. So such an interesting video, isn't it? So children, now with this, I'm ending the session of today's week. I hope you have enjoyed all the illustrations and have learned a lot. So children, you are required to go through all the illustrations based on inertia of rest and inertia of motion given on page number 62 and 63 of your physics textbook. And then kindly write down the answers of the tick marked questions. All the answers have been explained in the PDF and the video, and you can easily see all the answers given on page number 62 and 63. So thank you, students, and have a nice day.